Now we're going to be taking a look at the parent function for the graph of y equals the cosine of x. So before we do this, let's discuss the phase shift form of the cosine graph function. What we're going to do is analyze this piece by piece and dissect each component of the cosine function. The first thing that we note in phase shift form, y equal a cosine k times x minus b, is that a corresponds to what we call the amplitude. So this tells us again how high or how low the graph will stretch, okay? And it will move opposite the direction. It will move directly with the sign. If it's positive, it'll be a normal cosine graph, and we'll take a look at what that looks like. If it's negative, it'll be a reflection across the axis. So keep that in mind. We always think about the amplitude in terms of a positive value, so we take the absolute value of whatever the amplitude is to determine how far it stretches or shrinks. But the negative sign will tell us or indicate that it is a reflection. The next thing we'll talk about is the period length. The period length of a cosine graph corresponds to how long it takes for a cycle of cosine to repeat. Now the period can be modified by this value k in the phase shift form. You would take the period 2 pi for the cosine parent and divide it by k. B corresponds to what we call the phase shift, and it will move opposite the direction of the sign. Now let's go ahead and take a look at y equal cosine of x by using the values given on the unit circle. So remember that the cosine graph, or the values for cosine rather, correspond to the x values for each of these terminal points that we're going to be looking for. So we're going to start off with 0 radians. At 0 radians, we look and find the x value. The x value at 0 radians corresponds to the value 1. So at 0, we're going to put a value or a point at the point 1. So let's go ahead and first indicate 3 units up, 3 units down, that we have 1 and negative 1. And we will begin by putting our point at 1 for 0. The next value that we're going to look at is pi over 2. The value of cosine at pi over 2 is given here on the unit circle as 0. So at pi over 2, we're going to indicate 0. The next value we're going to take a look at is pi. The value for cosine at pi is negative 1. So we go down to pi and below to negative 1. Okay. The next value we're looking for is 3 pi over 2, and the corresponding x value for 3 pi over 2, which is cosine, is 0. So we indicate 0 on the graph here. And then we take a look at 2 pi. And 2 pi, yet again, we are back at 1, which is right up here. The last thing that we do for this parent function is connect the dots. Okay. Now you'll notice that the cosine graph looks kind of like an inverted bell, if you will. But notice that you can continue this graph and it will continue to cycle. So this is only one period of the cosine function. And notice the length of the period. It takes 2 pi units for it to repeat. So the period of the graph is 2 pi units. Now we can notice something about the amplitude. How high to up does it stretch? How low does it stretch? Well, it stretches in either direction 1 unit. So the amplitude of the cosine graph is 1 unit. So let's go ahead and move our unit circle out of the way and take a look at a problem where we can apply the techniques we just learned. Okay, taking a look at this function here, y equals 3 over 2 cosine of 1/3 x, we should note that our amplitude has certainly changed. So we're going to make a note of that. Our amplitude in this case is going to be 3 over 2 units. So about 1.5. Well, exactly 1.5 to be certain. All right. Now we should also note that our period will be modified, but there is no phase shift. In other words, the graph will not move left or right. So let's go ahead and take a look and see what we've got here. We have an amplitude of 1.5 and a period corresponding to 2 pi over k and our k value happens to be 1/3. So we're going to take 2 pi and divide it by 1/3, which is the same as taking 2 pi and multiplying it by 3/1, which gives us a period of 6 pi units. Now, to find those tick marks, okay, and the tick marks are just the steps for each of these functions here. They're the increment by which we advance. So when we had the marks here, that was the first tick mark, the second, the third, the fourth, and then the fifth. Okay, so to find those tick marks, what we're going to do is take the period and we're going to divide it by 4. So in this case, our period was 6 pi, and we're going to divide it by 4. So you can reduce this. You can get 3 pi over 2. All right, so let's go ahead and take a look at our marks. Now notice that there is a 4 pi indicated on there, but I'm going to actually scratch it out because that's actually not correct for this graph. We're going to take it a 0 at our origin, and we're going to write our first point, which was 3 pi over 2, because that's how far away the first tick mark is from the origin. The next mark will correspond to 6 pi over 2, which is just 3 pi. The mark after that will be 9 pi over 2. And the final mark will be 12 pi over 2, which is our period length of 6 pi. Okay, so now that we've got those out of the way, we're going to take a look at the corresponding values here for the cosine graph that we looked at. And then that's going to be our guide for graphing this function. Okay, so remember that we start at the amplitude, and the amplitude that we saw here was 1.5 units. So we're going to start at the amplitude of 1.5, which is right up here in between 1 and 2. And then the next mark will come down to 0. So at 3 pi over 2, we're back at 0. At 3 pi, we will hit the amplitude again, which in this case is a negative 1.5 y value. At 9 pi over 2, we'll come back up to 0. And at 6 pi, we'll come back up to 1.5 right there. And then we will connect the dots. And we see here, we do have still that inverted bell shape. Okay, it's just narrower, because what we've done is we have extended, in this case, the period. And again, it's skewed because of the scale of the graph. Okay, we have increased the size of the period, and therefore we have decreased the frequency. And what do we mean by frequency? Frequency, we mean how often it cycles. But this does have applications to physics when I do speak of the word frequency. Okay, so frequency and period are inversely related. All right, again, we're taking a look here at the graph of the parent cosine and one view of the cosine by applying changes to the amplitude and period. As always, I hope this video was helpful, and remember, like and subscribe.